Okay, so looking at question 3 here, we have some scores. So this time we're not given the information of the mean and the standard deviation. We're asked to find that. So first we're asked to find the median, and remember, to find the median what you're going to do is order the data. You cannot find the halfway point through the data without ordering it first. When you order it, you've got 26 numbers. And if it's even, remember, to find where you're going to have your median value, you're going to have to do a half times n plus 1. So that's going to be, in our scenario, a half times 26 plus 1. So we're going to get 27 over 2, which is going to work out to be 13.5. So our value for our median is going to be between values 13 and 14. So there's a 1 in between that. So you'll have to order them. You'll have to find out then where is the halfway point between 13 and 14. What number will exist there? And if you do that, you should get a value of 87.5. So that should be a basic calculation for you all at this point. The next one is the mean. The mean you can do in your calculator. Okay, you are able to calculate that in your calculator using your statistics mode. You input your data into that table, and then what you're going to do is clear the data, go to stats, go to variables, and you're looking for the mean symbol, which on your calculator should be X bar. In this scenario, when you do that, you should get 85. The mode, if you remember, the mode is the most common. So what is the most common? Which one appears the most? And if we take a look, we will see that the number 90 appears 1, 2, 3, 4, 5, 6, 7 times out of the 26. So 90 is our mode. And our standard deviation then is going to be approximately 10.6. Now, in this scenario, we don't have a huge amount of data, and it's resulting in there being slight differences between our mode, median, and mean, but we're going to approximate it to be normal in this question, and so we're going to work with the mean score here. I know that here is going to be 85, standard deviation of 10.6, so that puts me at 95.6, and it puts me at 105 point, no, it puts me at 106.2. 106.2, and then we're going to have down this side 74.4, and we're going to have 63.8 down this section. Now, from what we're looking at here, the test is not marked out of 100%. It can't be, because of the 106.2. That's telling us that it must be marked. This must be their marks achieved out of perhaps maybe 150 or out of 200. But looking at the questions, then it says how many scores are within one standard deviation of the mean. So within one standard deviation of the mean, we will have 68% of our population. But they don't want to know the percentage, they want to know how many scores. So it's going to be 68% of 26. And if we do that, we're going to get 18. How many scores are within two standard deviations? So how many scores? We are going to have within two standard deviations is 95%. So 95% times 26. And if we do that, we're going to get 25. So 25 scores within two standard deviations. It then says, in statistics, scores are measured, or measurements that are greater than two standard deviations away from the mean are considered abnormal. Are there any scores here that are abnormal? So is there any ones that are going to be outside of the two standard deviations? So we're talking about something bigger than 106.2. And if we look at the data back up here, there is no value there that's going to lie above our 106.2, and there's actually nothing below 63.8 either. Okay, so there's nothing that is 2 standard deviations away, or nothing that is 2 standard deviations below, so too high or too low. So in question 4 here, we're now starting to move away from the curve, and we're just talking about the standard deviation and the mean, and we're asked to complete the sentences. So 68% of all tires will have a lifetime between blank and blank. Well, how are we going to figure that out? Well, if we read the question from the top, we've got a mean life. The mean is going to be 30,000 and a standard deviation of 2,000 kilometers. So remember, 68% is 1 standard deviation away on either side. So we go 1 back, which gives us 28,000, and we go 1 forward, which is 32,000. We have then 95% of all tires will have a lifetime between blank and blank. Well, 95% is associated with 2 sigma, 2 standard deviations away. So in that scenario, I'm going to take away another 2,000, and I'm going to be at 2,600. And if I go forward, then I'm going to be at 34,000. So we add on another 2,000 and we take away another 2,000. It then says if a company purchases 2,000 tires, blank tires would last more than 28,000 kilometers. Now, to figure that out, I'm going to draw a mini sketch of the curve for myself. So we know that that's 30k there, and we know this here was 28, and they're asking how many people were above that, or sorry, how many tires were above this, because it works for objects too. So we're going to have 28 and 30, and we want to know that section up there. Well, remember, after the mean, that's 50%, and this in here is 34%, right? Because it's the segment 1 standard deviation below. So we're looking for 84% of 2,000. So we're going to work that out. So what's going in here is 84% of 2,000. So if we do that, then we're going to get 84% of 2,000, and I'm going to get 1,680. So 1,680 tires of a batch of 2,000 would last more than 28,000 kilometers. The next one, in an Oreo factory, the mean mass of a cookie is 40 grams. For quality control, the standard deviation is 2 grams. 10,000 cookies are produced. Blank cookies are expected to be within 2 grams of the mean. Okay, so remember, 2 grams is the standard deviation. So what percentage of cookies then are going to be between 42 and 38? And remember, 1 standard deviation away, because that's what our 2 grams is, 1 standard deviation away is 68%. So I want 68% of 10,000, and if I do that in my calculator, I will get 6,800. The next one, cookies that are more than 44 grams and less than 36 grams are rejected. In a batch of 10,000 cookies, blank would likely be rejected. So we're talking about now 2 standard deviations away on either side of the mean. So a little sketch here to help us. But here's our mean of 40, and either side of that 2 standard deviations away is 44. The higher end, and 36 down here, and we know between there and there is going to be 95%. Anything outside of that, so in this region or in this region, is rejected. So if I know 95% exists within the pink region here, that's what's accepted because it's between 44 and 36. And how did I get 95%? 2 standard deviations. We're 2 standard deviations away from 40. So I'm looking for 5% of 10,000, and if I do 5% of 10,000, then I'm going to get 500 cookies. Those are how many would be rejected. In question 5 then, the battery life of an iPhone is 6 hours. The standard deviation reported by Apple is 30 minutes. After several days of measurement, Tom finds that his iPhone charge holds for an average of 5 hours 45 minutes. Is this cause for concern? So this question was trying to get us to look at the data and interpret, well, is this an abnormal result? And remember, if it's within 2 standard deviations, we consider it to be normal. Okay, his is 5 hours 45 minutes. That's only 15 minutes of a difference. So 15 minutes difference between his iPhone and the mean, which is 6. The standard deviation is 30. So he's not even 1 standard deviation away. He's actually half a standard deviation away. So that's not cause for concern. It's well within the normal range. So 68% of them would lie between 5 hours 30 and 6 hours 30. So he's well within the normal range.